In Activity 7, Weather Fronts, students discover what fronts are and learn how to track them on a weather map. They first investigate the different types of weather fronts, and then learn to interpret fronts and predict the weather they bring. Students also plot weather fronts on a map and finally update data on sections of their weather stations. You will need the following materials from the kit: Activity Sheet 7, pieces of 23 centimeter by 30 centimeter construction paper, paper fasteners, and weather stations. You will also need to provide markers and weather reports. To prepare for the activity, make a copy of Activity Sheet 7 for each student. Be sure to collect weather reports. Each team of 2 will need a marker, 2 paper fasteners, a piece of construction paper, and their weather station. To begin the activity, reference one of today's national weather reports. Ask students, how does today's weather compare with yesterday's weather? The 2 reports will likely differ. Then ask, why do you think weather changes? Accept all reasonable answers. Next, explain to students that air mass is the term used to describe a vast body of air in which the temperature and/or the amount of moisture are much the same throughout. Air masses are constantly traveling across the surface of the Earth, creating our weather as they go. Inform students that a weather front is the boundary where different air masses collide. When this happens, weather changes. Explain that a cold front forms as a mass of cold air advances to displace a mass of warm air. Similarly, when a warm mass of air overtakes a cold mass of air, a warm front is formed. Ask students what would happen if a mass of warm air were advancing toward a mass of cold air. Because warm air is less dense than cold air, it would rise up and ride over the cold air. Let students know that warm air contains more moisture than cold air. Now ask, what would happen if the warm air contained a lot of moisture? As the moist warm air rose up higher into the atmosphere, any water vapor in the air would be cooled, causing it to condense or turn to liquid. Then ask students, what kind of weather do you think warm fronts bring? Why? Warm fronts slide slowly above the cold air, so more air cools, causing condensation and precipitation, clouds and rain. Because the warm air is the mass that moves in, storms are usually followed by hot and humid weather. Now, ask, what kind of weather do you think cold fronts bring? Why? The denser cold air dives under the warm air, pushing it upward. Again, the warm air cools, and any water vapor condenses and produces precipitation. This time, however, because the cold front is moving in, cooler temperatures follow the rain. Explain that occluded fronts occur when faster-moving cold fronts catch up to slower-moving warm fronts. The warm, moist air is pushed up as the cold front encounters cool air. Stationary fronts occur when a cold and warm air mass meet, but neither move. Ask, what kind of weather do you think occluded fronts bring? What about stationary fronts? Why? In an occluded front, the warm air mass, being lighter, is pushed above the 2 cold masses. Up high, the air becomes cooler and its water vapor condenses. Therefore, occluded fronts usually bring clouds and rain, but less extreme conditions than cold fronts bring. With a stationary front, neither the cold nor the warm air is advancing, and widespread clouds can form on both sides of the frontal boundary. Since the clouds are barely moving, a stationary front often brings lengthy periods of precipitation. Show students the symbols that designate the type of front. Next, distribute Activity Sheet 7 and the materials. Ask students to draw the symbols for each type of front on their activity sheets and answer question 2. Have students retrieve their weather stations and look at the previous few days' national maps, noticing the direction that the